Hello and welcome back. Very good morning, good afternoon, good evening, my friends. I'm your friend Maruti Makwana, and I'm back with the most awaited and the most important Azure course, which is AZ-400. After so many requests from my lots of students, actually, we have finally achieved AZ-400 recorded course. This course is focusing on Microsoft Azure DevOps. So yes, we have a course on official certification, which is designing and implementing Microsoft Azure DevOps solutions. This course is obviously an expert level course. So if you are already familiar with Azure fundamentals, you are Azure developer or an Azure administrator, then maybe this advanced level course is a perfect for you if you want to master your DevOps skills with Microsoft Azure Cloud. Let me take you through the full course overview and what exactly you need, or whether this is going to be a right course for you or not. So let's get started with this. The first thing I want you to see right now is this link, which is actually an official link of the course, which is designing and implementing Microsoft DevOps solution. Now, this is that link which is actually going to take you to A to Z of all the topics which actually we are going to cover in this course. So we are going to start with development for enterprises using DevOps. We are going to focus on implementing continuous integration with Azure pipelines. And there is some part of this which is GitHub Actions also. And same way, each and every topic, each and every module which is part of this official course, we are going to do that particular thing in this particular course actually. So this is a self-based learning. You're going to watch these videos, and exactly after each and every module, we have a labs associated with that, which I strongly recommend you to do it practically. Now, this course is actually going to be focusing on this certification exam, which is obviously AZ-400. That's an exam certification code. Now, as you can see right now, we got the latest update of this exam on May 3rd, 2024. And that's the reason we are recording this particular one exactly after a month, which is June 2024. This course is having all the updated changes which are there up to this particular date. And yes, you can trust on me. This is the updated course, which is actually having all the latest things which are mentioned on the official site link. The flow, the topics, the weightage, everything is going to be same like the official course which are there on the Microsoft curriculum. Also, once you are dealing with AZ-400, as I told you, first check whether you are the right person for the certification exam or not. And the answer of that is going to come from this link, because if you see right now, this is showing you that there is one prerequisite for this particular exam, which is actually you want to earn Microsoft Certified DevOps Engineering Expert. If this is a title which you are willing to earn, then you can click on that, and then it's going to take you to a track where it is showing that there is a prerequisite exam, and there are two certifications which can be part of this prerequisite. When I click on that, it's going to take me to the page where it's showing me that before you go for AZ-400 exam, you should actually go for AZ-104, which is Microsoft Azure Administrator Associate, or AZ-204, which is Microsoft Certified Azure Developer Associate. In short, you should be very good in either administration part of Azure or a development part of Azure. Then only you will be a right candidate for AZ-400 course. So if you have not cleared any one of those things, I strongly recommend you to go through our AZ-104 and 204 courses, and then you can go for AZ-400. This is going to be a little advanced for you. But anyone who's there in the industry from more than, I think, 15 years or maybe 12 to 15 years, this course is going to be a super value add-on for yourself. So if you're going for this, it's going to be one of the expert level tough course. But yes, you have your friend Maruti with you, so don't worry. I'll help you whenever you need me. Next thing is, when you're going for this course, labs are a very important part. We are official partner with Skillable, which is a learning management system and training management system provider. And this is also official partner with Microsoft also. When we are providing labs for most of the corporate clients, we actually use Skillable with that. So we are partner with Skillable. I can give you labs which are managed by Skillable, and it's going to give you a full cloud level access for one particular course. So we are talking about AZ-400, and for this particular course you are going to get a lab access of Azure Cloud for 30 days, and in that you're going to get a separate Azure subscription. Now all these labs, all this configuration of Scalable is available to you by us, but this is something which is chargeable because we also have to pay to Scalable, and if you are connected with the cloud, you know cloud is never free. So if you want to have a lab access, you can just connect to us on our registered official number, which is 9081908127. It's an Indian registration number, so you can just put +91 before that, and you can reach out to us on that number using WhatsApp also. Now when you are doing that thing, remember one thing, these labs are not free of cost like this course. This course is free, learning is free, but if you want to use cloud, either you have to register a subscription by yourself on Microsoft, or you can use these labs for which also you have to pay a certain amount. So you can connect with our backend team and they will guide you on that. Suppose you already have an organizational level subscription, or if you have your own personal subscription, then you don't need to use these labs. Like you can see, this is a lab which is actually associated here, and this lab is actually officially for AZ-400, and when you go inside that, it's going to provide a step-by-step instructions. You can just launch the lab and you'll get the Azure Pass also, which is a provided subscription associated with that. But yes, as I said, this is chargeable. Not all the students are actually willing to pay for the labs, and if you already have your subscription because of your organization, then there is no point of paying for the labs. In that case, you can go to this third and the final link, which is the official link of a GitHub repository of Microsoft Learning. This repository is showing you same labs instructions. So this is not giving you a lab environment, but it's showing you each and every official lab, and with each lab you're going to have step-by-step instructions available inside that, which exactly you have to do. Now these instructions are available in Scalable also, but with the subscription and lab environment, while in this case it's only a GitHub repository which is actually going to have only step-by-step instructions. You have to follow those instructions in your own Azure subscription. That's the difference, but you don't need to pay anything to anyone in this case. Now this is the official link. I'm going to show you all these 3 useful links before you get started with AZ-400 course. Just make sure you're the right person for this course, and if that is true, if you're matching with the requirement, you decide whether you want to go with which lab, and then you can just get started with the first module of this course. This course is having 9 modules and approximately 15 labs inside this. Each lab, each module is very important. I strongly advise you to do this thing consistently in one single month. That is something which is a secret of clearing the certification and gaining all the knowledge in one shot. Do not try to stretch this thing for longer than 1 month. That's something which is very unhealthy decision, because we are human beings, we forget things very quickly. When you're starting the course and in the first 1 month, if you need any help, reach out to us on the same number which I have mentioned earlier, +91 9081 908127, and then I'll be more than happy to help you in that. So before we proceed to the actual module learning, which is the first module of this particular course, I want you to make a note of these 3 important links. As I have shown you in this video, the first link is going to take you to the official exam page. The second one is going to take you to the course, where each and every module with all the descriptions and all the theoretical concepts are there. And then the third link is going to take you to that GitHub repository where all the lab instructions are available. I wish you all the very best for your learning. Please focus on the course, give your 100%, spend every day a few hours for 30 days, and you'll be easily able to clear AZ-400. Thank you so much. All the very best. Happy learning. Okay, so now as we know, AZ-400 is actually having 9 different learning paths. Let's start with our first learning path, which is going to be starting our journey on DevOps. In this learning path, we have total 8 modules which we are going to focus, and after these 8 modules, we have 1 lab which we need to complete. The first module is focusing on Introduction to DevOps. We will understand what DevOps is actually. Please keep in mind, this module is focusing on DevOps, not on Azure DevOps. Azure DevOps is going to start after some time in the same module. After this, we have choose the right project, then describe team structure, and then choose the right DevOps tool. These 3 modules are going to talk about what kind of a project is a perfect choice for DevOps kind of an implementation, as well as what kind of a team and team members you can have, and then there are various tools which are available in the market, which DevOps tools you should choose. Then we have to plan for Agile with GitHub projects and Azure boards. And then we have to focus on source control. So we are going to understand what is a source control, what kind of flavors and options are available in that. And then in the module 7, we are going to describe the types of source control systems in that. Finally, the module number 8 is going to focus on working with Azure Repos and GitHub. So that's what the plan for learning path number 1. Let's get started. The overview of this learning path is going to have the same thing what we discussed. So these are the learning objectives which you will understand, which you will learn at the end of this learning path. As I mentioned, after completing this learning path, you will be able to understand this 8 different things which are mentioned there. And that's it. Let's move forward. We also have certain configurational things, like we have to understand the benefits of source control. We have to describe what is Azure Repos and how it is similar or different than GitHub repositories. And then we have to talk about migrating from your team foundation version control to Git. This is also something which we are going to discuss in the same learning path. Let's start with module number 1, Introduction to DevOps. Now, if there's a question, what is DevOps? The simple answer or the definition is DevOps is a union of people, process, and products to enable continuous delivery of value to your end users, to your customers actually. Now, this definition is actually given by Donovan Brown, and there are many guys who do not know about this definition. Actually, most of the time when we ask someone what is DevOps, they mostly answer DevOps is a combination of development and operational collaboration, which is also correct. But somehow this definition, which is talking about PPP, people, process, and product, is much more meaningful, because when we talk about people, we are talking about our developer and our operational teams only. We have to take our people and we have to give them one continuous process. A continuous process which is talking about coding, integration, deployment, and feedback. That continuous process is like an infinitive loop which is going to happen again and again repeatedly. And then, in order to make sure that our people are going to use this process, we have to make sure that they have the right amount of products and tools available for them, so that they can utilize the process impactfully without any mistakes. And that's what DevOps is all about. Now, if you understand this right now, we have a cycle which is repeatedly going to be executed. Now, you obviously have to understand your cycle time. You have to be informed about the data. So we recommend you to use data to inform what to do in your next cycle. So when you're having repeated multiple cycles, what you're going to do, what kind of validations and checking you're going to do in this particular cycle, and then what things you're going to do differently in the next value in the next cycle when you're going to do the improvements. This is what a continuous process is actually all about. Over a period of time, your cycle time is going to be shortened, and then you can get the results in a much quicker and a shorter way. And then this is how we are going to optimize and validate our learning. So when you are going to implement your DevOps practices, you should shorten your cycle by working with the smaller batches. You can use more and more automation in that particular cycle. You can improve your telemetry. You can also deploy more frequently. These are indirectly those advantages which you're getting when you are implementing DevOps. And that is where we are focusing when we understand DevOps. Now, we need to understand the DevOps journey. So we have to understand what are these two words. Technically, if you see right now, we have two words like continuous integration, continuous delivery. Obviously, we have one more option here after this, which is like continuous monitoring, or we call it feedback also. But yeah, let's start with these two first. First one is continuous integration. This one is going to drive the ongoing merging and testing of your code, leading into an early finding of defects. So when you talk about continuous integration, it's ultimately a build and test which you are applying on your code and your packages. The other benefits which includes in continuous integration is this is going to be less time wasted in this case. So when you're going to fight with merging issues and you want a rapid feedback kind of a thing from your development team, continuous integration is going to make sure that things should be rapid, things should be going with the continuous integration kind of a process. And then because of this, you will be able to achieve something which is continuous delivery. Continuous delivery of a software solution to production and testing environment is going to help your organization to quickly fix bugs and respond to ever-changing business requirements. This is where you have to make sure that the delivery to the customer should be continuous as well as it should be automated. So when we talk about integration and delivery, we have to make sure that things should be automated and things should be properly monitored and tracked. If we continue with the same thing, if I want to understand the DevOps journey with CI and CD, we have to understand two more things. As a concept, we need to understand the usage of version control. Version control usually comes with the Git-based repository, which enables teams worldwide to communicate effectively during your daily development activities, and it also integrates with software development tools for monitoring activities such as deployment. Now, with all this configuration of version control, obviously plenty of choices are available. You can use Git, you can use Bitbucket, you can use Azure Repos, or a couple of other options which are available. Which tool you have to use is your choice, but you need to have a version control in place so that effectively you can make sure that your new code changes has to be incorporated in that. Same way, you need to have an agile methodology, or there is another word which is known as lean methodology should be associated with that. So you have to use agile planning and lean project management techniques also, which are going to give you a benefits like you can plan and isolate work into sprints. So you can divide your one big task into a couple of smaller chunks and smaller tasks, and then it is going to be helping you to keep track of each and every task. Who's working on which task, which team is allocated with which kind of task work, how much progress they have done, what kind of things are still waiting for the approval from the higher authorized users. Everything you can keep track with this agile planning methodology. You can manage team capacity. It's also going to help your teams to quickly adapt to changing business needs. A DevOps definition of done is actually nothing but a working software collectively telemetry against the intended business goal. So ultimately the process is going to start with the to-do kind of a task which a team members has to complete, but at the end of that, done means it's like something which is already published to the production, which is ready to be used by the end users. And that's the full process of Agile, which we have to go through step by step. Finally, as we mentioned, that after continuous integration and delivery, we also have a continuous monitoring, which includes monitoring and logging. Now, when you have applications running, including in the production environment or maybe some staging or some kind of a testing environment, you need to have an application health monitoring, you need to have a customer usage monitoring, and this kind of monitoring is going to help organization to create a hypothesis and quickly validate or disapprove strategies. Rich data is captured and stored in the various logging formats, using which you can generate metrics, graphs, dashboards, charts, kind of things associated with that. These all configurations are also going to end up with one last thing, which is cloud. Public and hybrid clouds have made this impossible things which very easy, that the cloud has removed traditional bottlenecks and help your infrastructure has to be commoditized with that. When this is happening, you don't need to manage the huge infrastructures on your on-premise server. Your public clouds like Azure, AWS, Google Cloud is going to help you to integrate your DevOps tools and your project infrastructure services or platform as a services all at one place in a much manageable, easier way. No matter which kind of service you're using, whether you're using infrastructure as a service or platform as a service or some other third-party integration services, it's all available in one under single umbrella, and then you need to understand how you can automate and incorporate all with your DevOps cycle. Now the next piece of DevOps journey is infrastructure as a code. This enables the automation and validation of the creation and tear down of environments to help you deliver secure and stable application hosting platforms. When you're doing this thing, your infrastructures, your virtual machines, your hard disk, your other deployment resources can be automated with the help of a configuration. This configuration is mostly going to be in the JSON file formats, or maybe you're going to have a configuration like Bicep format or Terraform. There are so many infrastructure as a code kind of a tools available, which will make sure that before you push your code and publish your packages into your cloud or on-premise infrastructure, your infrastructure should be deployed and readily available on that. As well as you also have to change certain application level architectures sometime. You have to incorporate architectures like microservice architecture to isolate the business use case scenarios into small micro-sized reusable services that communicate via interfaces and contracts. This kind of a microservice architecture enables scalability and efficiency in your project. In traditional days, we used to use a monolithic or multi-layer architecture, which you also used to call entire architecture kind of thing. But in the modern days, when you are using DevOps, most of the time we restructure our application into a microservice kind of an architecture where everything is going to be loosely coupled, everything is going to be independently deployable. While this is not a mandatory thing, it is always advisable that you have to do the needful changes into your project architecture accordingly. Last but not the least, we have one final piece in the DevOps journey, which is containers. Containers are the next evolution in virtualization. They are much more lightweight than your traditional virtual machines, and they allow much faster hydration and easily configured files inside that. The reboot time, the self-healing kind of a mechanism of containerization has made this particular technology very popular. And containers are actually one of those things which most organizations are focusing really in depth whenever they want to make sure that the applications should be deployed on the infrastructures as a services or maybe on the third-party cloud in the hybrid infrastructure. Containers are one of the best choice for that. As you can see on the slide, they are saying that because of all these different aspects and different things which you have to take care in DevOps, it's not an easy job to integrate DevOps into your organization. Or maybe it's not an easy job to integrate DevOps with cloud and migrating to the cloud. But things which are not easy, things which may be hurt in the initial phases, those are maybe those most important things which you have to do it. Same like it hurts a lot when you go to gym, when you exercise daily. But that hurt is something which initially going to hurt you is going to be beneficial for you for a longer period of time. The same thing is happening with DevOps also. It is a tough thing. You need a good team. You need to restructure your project. You need to take care of a couple of things at different areas and at different aspects. But ultimately at the end of this, everything will be automated. Everything will be smooth and you will be able to deliver a value to your customers. That's what the most important thing. Now, once we understand what is DevOps, we need to explore agile development practices. Now, if you have already understood agile approach, then you may be already familiar that we have different approaches available. Like the older one is a waterfall approach. Waterfall approach is mostly going to have used in traditional softwares actually. It's mostly start with defining a problem, then analyzing the requirement, then building and testing the required code for that, and finally after that delivering the outcome to the end users or customers. These multiple stages which are available in waterfall model is a traditional approach to develop application. The waterfall model follows a sequential order, so it's always going to go step by step, one after another. Now, the waterfall methodology is extensively used in the past, but it has so many drawbacks, because of which we have an agile approach, which is much better than waterfall. Now, there are so many drawbacks of waterfall. I do not want to mention all of them, but one common thing is which is related to customer requirement. For example, when you have to go to stage number 1, when you have to define a problem, you have to determine a problem and you have to analyze the requirement with that. Most of the time it happens that a customer usually do not know what exactly they are looking for. The customer requirements are defined accurately at the starting of the project is almost impossible. Usually when the project is going to take more time, the outcome can also take longer time, and at the end of that, when we deliver something to the customer, by that time his initial requirements got changed. This is something which is a very common problem in most of the scenarios when you are applying waterfall approach. This is where we have another approach which is coming into the picture, which is agile. Because agile, by comparison of waterfall, this methodology constantly emphasizes an adaptive planning and early delivery with continual improvement. So in spite of going with the step-by-step process like waterfall, Agile is going to be focusing on early delivery with continual improvement. Means we are going to divide a small prototype of our project first, and then we are going to give it to the customer. We'll take the feedback of the customer, and then we'll again work on the next piece of that with those improvements and changes. Development needs to favor individuals and interactions over processes and tools. So when your customer collaboration is going to happen over a contract negotiation, or when development methods are going to be based on your release and iteration kind of thing, this is going to help your organization, as well as this is going to help the team members to develop the application in a much rapid and a proper way. At the end of each iteration in Agile approach, you should have tested working code. If you focus on a short-term outcomes, and if you divide your big things into smaller pieces into that, it's going to be easier for you to develop that project. After being estimated and prioritization with this, features, bug fixes, enhancements, and refactoring width are assigned to each and every release which is happening in Agile. There are so many nested processes which are associated with this. We are not going into in-depth right now, but traditionally what was done in the waterfall approach, we're having a couple of issues which is now going to be fixed with the Agile approach. Now these are the principles of Agile development. If you have already studied Agile, you already know these principles. Otherwise, you can see this link which is visible on the slide. These are the 12 different principles the Agile manifesto is using actually, and this is the link which is available on that. So I do not want to read all of these principles, but yeah, these are those principles based on which Agile methodology is based. When you want to achieve a DevOps integration properly with your project, you need to make sure that you have to identify a transformation teams with that. Because unless you are building an entirely a new organization, one of the significant challenge with any DevOps transformation project is taking actions that conflict. The first challenge is availability of the staff. Suppose the staff members leading the transformation project are involved in an existing day-to-day work within the organization. It's a challenging thing. It will be even more challenging to focus for the transformation when their current role is directly impacted with the customer outcomes. If they are already busy doing many other things, they will not be able to focus on the DevOps things. We all know desperate situations involving customers will always win over a long-term project like DevOps transformation. So another issue will be how the organizations are going to operate and implement an existing processes and procedures to support current business outcome. To overcome these challenges, you have to create a team that is focusing on the transformation, that is going to be well respected in their subject areas. They already have the domain knowledge association with that. And internal and external to the business are also familiar with them. So this is something which you have to make sure as a step number one. You need to have a transformation team. It should be placed in order to implement DevOps. One of the aim of DevOps is to provide more excellent customer value. So the outcome should have a customer value focused, because that's what we say. We deliver value to our customer at the end of the process of the DevOps cycle. Now these outcomes should include specific measurable targets. So all these goals, all these targets which you're focusing should have some measurement associated with that. Like you should have reduce the time spent on fixing bugs by 60%. You have reduced the time spent on unplanned work by 70%. You have reduced the out-of-hour work required by the staff to no more than 10% of total working time. These all are achievements. These all are measurable outcomes which we can achieve by applying DevOps things into that. And then removing all direct patching of production systems. Maybe sometimes we have to do that thing, but not all the time you're directly going to patch into the production systems. You have to go through the cycle wise this, and then if everything works fine, then only we are going to put things into a production environment. So one of this configurational things is what you have to define your timelines, and you have to define the goals which are measurable. Now in this case only, when we are focusing and we are saying that we have a measurable goals, you also need to have a timeline associated with that. While it's easy to set a longer term goal, and it is also easy to put off work when you do not require it for a while, it is essential to have an ongoing series of short term goals first. Overall project should have a timelines that span anywhere from few months to maybe a year or maybe 2 years. In any DevOps transformation project, this timeline can be longer or shorter, depends upon the project. The timeline should not be too short, and it should always be challenging yet achievable. A review should occur after each short-term goal and is going to help your team to plan for the next one. This is a best practice kind of a situation which we always have to follow. There are several advantages of a shorter timelines, like it's easier to change plans and priorities whenever required. It's going to reduce delay between doing the work and getting the feedback, because you have a shorter timeline. After every timeline done, you're going to take the feedback, and then you're going to make sure that new suggestions, new feedback improvements are going to be taken care in the next cycle. And it's also easier to keep organization support when positive outcomes are apparent. These are those advantages which shorter timelines are going to give us. Module number 2, choose the right project. In this module, we are going to talk about DevOps project, or what kind of projects are going to be perfectly matched for DevOps implementation and what kind of projects will not be. First, let's talk about greenfield, brownfield projects. Now, the term greenfield and brownfield have their own origins in the residential and industrial building projects. A greenfield project is one which is done on a greenfield, which is like an undeveloped land. A brownfield project is done on the used ground for other purposes. Now, because the land is already used and it has something which is already on that could be a challenging and reusing an existing land. Like existing buildings, some would be obvious but less obvious, like polluted soil. It all can be there. This is where greenfield and brownfield kind of a differentiation is coming. The short terms are routinely applied to software projects and commonly described as DevOps projects also. Now, when you're focusing on this, if you have a project where there was no existing code base, you do not have any existing team dynamics or politics, you have possibly no current or rigid processes associated with that, this is maybe something which is perfect for your greenfield software project. But if you already have certain things, and if your project is a brownfield project, then some client says that DevOps is not suitable for the brownfield project, which is again not true. The beauty of the DevOps is actually this, that it works with greenfield as well as brownfield, both the projects. It's not only for greenfield, it can be working for brownfield projects also equally the same way. Now, when starting a DevOps transformation, you might need to choose between greenfield and brownfield projects. A greenfield project will always appear to be more accessible starting point. A blank slate offers the chance to implement everything the way you want inside that. You might also have a better chance of avoiding existing business processes that don't align with your project plans. Suppose your current IT policies don't allow the use of cloud-based infrastructure. In that case, the project might be qualified for entirely new application designed for that environment from scratch. And this is the best example of a greenfield project. While in the other case, if I go for the brownfield projects, usually brownfield projects comes with the baggage of existing code base, existing teams, a significant amount of technical depth. Now, what is the technical depth? If you don't know right now, we are going to understand that in the coming modules. But yeah, it can have a technical depth, which are those issues which are already there with the existing code base. And then they can still be an ideal project for DevOps transformation. As I said, brownfield projects can also be an ideal one for DevOps transformation. Whether your teams spend large percentage of their time in just maintaining the existing brownfield application, you have a limited ability to work on the new code. So it is essential to find a way to reduce that time and make sure that software releases are going to be less risky. A DevOps transformation can provide that solution, and that's the reason it is going to be suitable for brownfield projects also. When selecting systems as candidates for starting a DevOps transformation, it is necessary to consider the types of systems that you operate. Some researchers suggest that organizations often used a bimodal IT, a practice of managing two separate coherent modes of IT delivery. One focus on stability and predictability, and the other one is going to be focusing on agility. Now in this case, we have two things association with that. We have system of records and we have system of engagement. System of record is that system that provides the truth about data elements and are often called system of records. These systems have historically evolved slowly and carefully. For example, it is crucial that a banking system accurately reflect your bank balance. System of record emphasize accuracy and security, and that's where the focus is going to be. In the other case, system of engagement is like many organizations have other systems that are more exploratory. These often use experimentation to solve new problems. Systems of engagement are modified regularly, and usually it is a priority to make a quick changes over ensuring that changes are correct. There are perceptions that DevOps suits system of engagement more than system of record. Now, the lessons from high-performing companies shows that that is not the case. DevOps are perfectly suitable for both type of systems, whether you are working with system of records or you're working with systems of engagement. DevOps is going to be a perfect suited for both. Identify groups to minimize initial resistance. Now, not all staff members within the organization will be receptive to the change required for a DevOps transformation. In discussions around continuous delivery, we usually categorize users into three general buckets. We have a user who are known as canary users. Canaries users are going to be voluntarily test bleeding edge features as soon as they are available. In short, they are the most positive ones. Then we have early adopters who voluntarily preview releases and considered more refined than the code that exposed to canary users. So it's going to have a refined code compared to the one which are maybe there with the canary users. And then after that we have the actual users who comes the product after passing through a canary and early adopters. It is essential to find a staff members who are keen to see the new features as soon as they are available and highly tolerant of issues when choosing canary. You need to segregate your team members into this kind of different types so that you can provide those specific code base for testing purpose, for validation purpose to those team members. Now, what are the ideal target improvements which we can do when we are choosing this thing? When starting, it is essential to find an improvement goal that can be used to gain early wins. It is small enough to be achievable in a reasonable time frame, and it has the benefits that are significant enough to be evident to the organization. These are going to be focused as the ideal target improvements which your team has to focus on. Now, we spoke earlier about the importance of shared goals. It was also agreed upon by team members that the goals need to be specific, measurable, and time-bound. So it is essential to establish an appropriate metrics or key performance indicator to ensure that these goals are measurable. Now, while there is no specific list of metrics and KPIs that apply to all DevOps projects, the following are some commonly used ones. Like first one, which is faster outcomes. Deployment frequency, deployment speed, deployment size, and lead time is all going to be focused on the faster outcomes. So how frequently your deployments are launched, it is necessary to reduce the time that they take. How many features, stories, and bug fixes are being deployed on each time? That depends on deployment size. And then lead time, like how long does it take from the creation of a work item until it is actually completed. This is all going to be measured as one key performance indicator. You also have to focus on efficiency, where we have server to admin ratio, like are the projects reducing the number of administrators required for a given number of servers, or it is increasing it. Staff members to customer ratio, is it possible fewer staff members to serve a given number of group of customers? Application usage and application performance, how busy your application is. Is your application performance improving or dropping based upon the metrics which are visible for that application? Third, we have quality and security, where we have deployment failure rates, application failure rates, mean time to recover if any failure happens, bug report rates, test pass rates. All these are going to be coming under the quality and security kind of thing. Now you have to continuously monitor your application for availability, for service level agreement, whether it's achievable and it is achieving that or not. You have to focus on mean time of detection. And finally, the fourth one is you have to focus on the culture. Your employee morale, your employee retention rates are increasing or decreasing. When you focus on all four areas, you will identify the proper project metrics based on which you can understand your KPIs which are associated with your DevOps implementation. Okay, now in module 3, we are going to talk about team structures. Now, starting to apply agile practices in your company is not easy. It demands collaboration from your teams, stakeholder support, and training. This module is going to explore about agile development practices and is going to help you to define and configure teams and tools for collaborations. For most organizations, recognizing to be agile is difficult. It requires a mind shift and a culture shift that changes many existing policies and processes within the organization. As you can see in this slide, mainly we have two different kind of teams configuration: horizontal team structure as well as vertical team structure. Traditionally, horizontal team structures divide teams according to the software architecture. In this example, you can see that the teams have been divided into the user interface, service-oriented architecture, and the data teams, kind of three different segregations. On the other hand, vertical teams span the architecture and are aligned with the product outcomes, and scaling can occur by adding more teams into that. On the other hand, vertical teams structure span the architecture and align with skill set or disciplines. Vertical teams have been shown to provide more good outcomes in agile projects. Each product must have an identified owner. Another key benefit of the vertical team structure is that scaling can occur by adding more teams into that. For a successful DevOps transformation, the aim is to find team members with the following characteristics. First, they already think there is a need to change. They have previously shown an ability to innovate. They are already well respected within the organization, and they have a broad knowledge of the organization and how it operates. Ideally, they already believe that DevOps practices are what is needed for solving the problem. When they first start an agile transformation, many teams hire external coaches and mentors. Agile coaches help teams and individuals to adopt agile methodologies or to improve the current techniques and practices. They must be agents of change by helping people understand how they work and encouraging them to adopt new approaches. Agile coaches typically work with more than one team and remove any roadblocks from inside or outside the organization. This work requires various skills, including coaching, mentoring, teaching, and making it things easier. Agile coaches must be both trainers and consultants. Effective collaboration is critical for well-functioning agile teams. Enabling it requires cultural changes, cross-functional team collaborations, and tooling. That's the reason these are the three important parts which we are going to discuss in this slide. First, cultural changes. As it becomes harder to find the required staff, great teams will be as comfortable with remote work from home as well as maybe working from office. To be successful, though, collaboration via communication should become a part of the organization's DNA. Then you can have a cross-functional teams. Team members need good collaboration. It is also essential to have a great partnership with wider teams to bring people with different functional expertises together to work towards a common goal. Often there will be people from other departments within an organization. Faster and better innovation can occur in these cross-functional teams. People from different areas of the organization will have different views of the same problem and are more likely to come up with alternative solutions to problems or challenges. Third, you have to focus on collaboration tooling. So you need to focus on agile teams commonly use couple of collaboration tools like Microsoft Teams, Slack, GitHub, Dropbox, Jira, Asana, and many more other. You need to make sure that your teams are well equipped with this kind of tools so that they can easily collaborate and communicate. While developing agile methods does not require a specific tools, it can often enhance the achieved outcomes. It is essential to realize that the vital tool for agile development is the process itself. Physical tools such as whiteboard, index card, sticky notes are all required. Project management tools such as Kanban boards for planning, or maybe you can use Azure boards, or you can use certain tools for monitoring, visualization purpose. You should also have a screen recording tools for recording bugs and building a walkthrough or demonstrations for other team members and customers. Apart from Azure DevOps tools and GitHub, there are other standardized tools which can include things like Trello, Active Collab, Agilo from Scrum, Spira Team, iScrum, Gravity, version 1, and there are many more. Now, as we are talking about tools, now let's choose the DevOps tools. So what is Azure DevOps? Up to this point, we already know what is DevOps, but now let's talk about Azure DevOps. Technically, Azure DevOps is a software as a service platform from Microsoft that provides an end-to-end DevOps toolchain for developing and deploying software. As you can see on screen, this Azure DevOps is a suite of these 5 different tools: Azure Boards, Azure Pipelines, Azure Repos, Azure Artifacts, and Azure Test Plan. Combination of these 5 things are going to create one thing which is known as Azure DevOps Service. Azure Boards are useful for agile planning to keep track of who's working on which task, and likewise it can give you a visualization and reporting tool for multiple tasks of your project. You can have Azure Pipelines, which are ultimately allowing you to configure CI/CD, continuous integration, and continuous delivery with build and release pipeline. You can choose what kind of deployment options you want to associate, maybe an infrastructure-based virtual machine or containers and Kubernetes. You have Azure Repos, which are cloud-hosted public and private repositories, which are available on Azure DevOps. You can have an unlimited repositories with multiple branches, and you can use it exactly same like your Git repositories. Fourth one is Azure Artifacts, which provides an integrated package management configuration with support for Maven, NPM, Python, and NuGet packages. If you have reusable packages in your project and you want a centralized shared repository for them, Azure Artifact is a perfect public or private source for that. And finally, we have a fifth one, which is Azure Test Plans, which provides an integrated manual and exploratory testing solutions inside that. These testing tools will help you to make sure that before you compile the project and make sure that your build package is ready, or before you deploy to your prod environment, whatever testing tools, whatever testing things you have to check, all these things will be taken care by Azure Test Plans. Because we are talking about tools, let's talk about GitHub. What is GitHub? Now, GitHub is also another software as a service platform from Microsoft that provides Git-based repositories and DevOps tooling for developing and deploying software. Mostly GitHub provides also 5 things: code spaces, which provides cloud-hosted collaborative development environment. It provides repositories, where your developers can have an on-premise Git repository integration. It can have public and private projects integrated with that. It also has certain actions where you can create automation workflows with customizable variables for environments, and then you can also have a customized scripts association with that. You can have packages which can help you to easily integrate with numerous existing packages and open source repositories. And finally, it also provides a security where review your code and identity vulnerabilities can be found easily, and most of the time it is helping you to find these vulnerabilities very early in the development cycle, which is one of the good things. Because we are talking about security, Azure DevOps services use enterprise-grade authentication to protect and secure your data which you can use. You can use Microsoft account, you can use GitHub account, or you can also use Microsoft Entra ID to protect your environment. You can use personal access token for tools that don't directly support Microsoft account or Microsoft Entra ID for authentication. Azure DevOps is pre-configured with default security groups. Default permissions are assigned to the default security group automatically. You can also configure access at the organization level, collection level, project level, or maybe a particular object level. Conditional access policies and multi-factor authentication can also be integrated to minimize the risk of compromised credentials in Azure DevOps environment. Both Azure DevOps and GitHub can be integrated with different kinds of work management tools. As an example, in Visual Studio Marketplace, Microsoft offers Trello integration tooling. We also have a free, flexible, a visual way of organizing anything with anyone in the Trello integration tooling. We have something which is Solidify, which offers a tool for Jira to Azure DevOps migration. And not only that, we have so many other third-party organization-specific tooling which are available at the commercial basis to assist with migrating other work management tools like AHA, Bugzilla, and ClearQuest. List-wise, there are so many work management tools which are available. Which one you're going to use for your project, that's something which you and your team are going to discuss and decide, and according to that you have to use it then. Apache JMeter is one of the popular open source software written in Java and designed to load, test, and measure performance of your applications. Same way we have a Paster, which is a tool that can automate the testing of PowerShell code. And then we have one more tool which is known as SOAP UI, which is a testing framework for SOAP and REST-based services. These other tools are helping you when you're going to migrate and integrate your existing test management facilities. If you are using Microsoft Test Manager, you should plan to migrate to Azure Test Plans instead of all these tools. Azure Test Plans are helping you to track your sprints and milestones configuration with that. When designing a license management strategy, you first need to understand your progress in the DevOps implementation phase. Licensing is undoubtedly a very important part of every project. Azure DevOps can be licensed for individual services or for users. It offers free and paid tiers also available on this. You can check this link which is visible on slide, and you can get more details about the pricing because it's changed very frequently. GitHub can also be licensed for individuals, teams, and for enterprises. Most probably your organization is already using one of the license of GitHub if you are already familiar with GitHub integrations and all. If you have a draft of an architecture, if you're planning for DevOps implementation or migrating your existing project to DevOps, you already know the part of the resources which you're going to consume, and that is going to help you to identify what kind of licensing, what kind of configuration you need to do inside that. You need to consider what phase you are in right now in the development stages. How many people are using those features? How long you're going to wait if the queue for your pipelines are going to be executing. Because there are chances you'll have multiple team members who are going to execute Azure DevOps pipelines at the same time. If that is the case, you need a parallel processing configuration for that. And you need to purchase a separate parallel jobs to execute your pipelines in parallel. These are all things you have to keep in mind while designing your license management strategy. Okay, now in this module, we are going to introduce you to GitHub projects, GitHub project boards, and Azure boards. And that's where we are actually planning for Agile. Now, when we have project boards, I'm sure most of the organizations are using either this or that tool for different kind of a project tracking. During the application or project lifecycle, it's crucial to plan and prioritize work. With project boards, you can control specific feature work, roadmaps, release plan, etc. Project boards are made up of issues, pull requests, and notes categorized as cards. You can drag and drop into your chosen columns, and most of the time the columns are going to look like this, which is visible on the slide. You can have a to-do column where you're going to have newly created task. You can have in progress column, you can have approved column also, you can have done column, something like that. So there are different types of project boards which are available. You can have user-owned project boards which can contain issues and pull requests from any personal repository. You can have organization-wide project boards also, which can contain issues and pull requests from any repository that belongs to a particular organization. Or you can have repository project boards which are scoped to issues and pull requests within a single repository. We also have Azure DevOps specific Azure boards. Azure boards is a customizable tool to manage software projects supporting Agile, Scrum, and Kanban processes by default. You can track work, issues, and code defects associated with your project using Azure boards. Also, you can create your custom process templates and use them to create better and more customized experience for your company. You have multiple features and configurations to support your teams, such as calendar views, configurable dashboards, and integrated reporting. The Kanban board is one of the several tools that allows you to add, update, and filter user stories, bugs, features, and epics. All these are easily customizable, and in the first lab of this module, we are going to focus on Azure boards in depth. We can link Azure boards and GitHub together. You can use Azure boards to plan, track your work, and GitHub as a source control for software development. Connecting Azure boards with GitHub repositories, enabling linking GitHub commits, pull requests, and issues to work items into that boards. This integration is supported by Azure boards, and it's going to be helping you in the following connections. Maybe you want to make a connection from GitHub, maybe you want to make a connection from Azure boards. It's going to work vice versa. While connecting GitHub and Azure board, you can take care of authentication and authorization. You can use GitHub username also and password, or maybe you can generate a personal access token using which you can authenticate your each and every request. You can use a project board template to create a project board with automation which is already configured. You can also copy a project board to reuse its customizations for similar projects. GitHub project creation and configuration is endless possibilities are associated with that. You can link up to 25 repositories to your organization or maybe to your user-owned project board. Once you have created your project board, you can add issues, pull requests, and notes to it. It's easy to configure and easy to manage. GitHub projects also allows you to control project deliverables, release dates, and iterations to plan your upcoming work. You can create an iteration to associate items with a specific repeating block of time, or maybe to set any length of time, which includes breaks also. It's possible to configure your project to group by iterations to visualize the balance of upcoming work. We have a customized project views. Using this kind of project views, you can organize information by changing the layout, grouping, sorting, and even filtering your work. You can create and use different visualizations. Use the project command plate to change settings and run commands in your project. You can use a different kind of short tools, like you can do command plus K in your Mac machine, or maybe control K in your Windows and Linux machine, and you can configure this thing. You have multiple commands to apply, such as switch layout, show, sort by, remove, sort, group by, remove by. All these commands are actually mentioned here on the slide. Finally, we have a GitHub discussion. Now you can collaborate using this kind of a team discussion, which can help you to make your team plan together, update, and they can also communicate with each other about updates. You can talk about any topic you'd like to discuss, post your team's page is in organization, or you can use team discussion for conversations that span across projects or repositories. When team discussions are associated, you can actually post on your team's page or a particular in a public discussion. You can link to a particular team discussion to reference it elsewhere also, and you can pin important posts to your team's page so that everyone can see those pinned posts every single time. You can also receive an email or a web notification whenever someone is adding certain comments on those pinned posts. Now, this is one of the demo which is allowing you to use GitHub projects, boards, and projects. We are not going to focus on this demo, but the link is going to be available on Microsoft Learn website if you want to try that. We are going to focus on Azure boards, and that's the reason, that's what we are going to focus on the labs. But work-wise is more or less going to be similar. You can add this kind of cards, and then in each card you can configure tasks, you can assign, you can drag and drop them into multiple columns. And that's all we can do in Azure boards as well as GitHub project boards. Okay, now in module number 6, we are going to talk about source control. This module is going to be taking care of basics of source control and is going to explore the benefits and best practices associated with that. Now, what is a source control? The source control is a common sense aspect of programming. It is essential from time to time to look at why we do what we do and how versioning impact the entire value stream at an organization. Now, this is where source control is going to be very impactful, because this is going to help you to manage your release software quickly and efficiently, while also maintaining the high level of security associated with your project. We have a DevOps foundational practices which we can apply, and as you can see here on the slide, in the foundational practices of DevOps and multiple stages, we strongly recommend that you should configure version control which are associated with that. Now, when we are controlling this thing with the version control, source control is going to be part of that. Most people get confused between version control and source control. So let me clarify that first, and then we are going to move forward with this. But as you can see here right now, in different stages of DevOps foundational practices, version control is a very important part, especially when you're dealing with multiple team members or multiple teams in the single project. These are the multiple stages. These are the stage number 3, 4, and 5. It's the same thing which we are discussing. Now, let's talk about what is a source control actually. A source control system, which is also, you can call it a version control system, allows developers to collaborate on code, and they allows them to track changes associated with that. You can use version control to save your work and coordinate code changes across your team. Source control is an essential tool for multi-developer project, and that's where it is going to be most suitable. The version control system saves a snapshot of your files, which we call history, so that you can review and even roll back to any version of your code with ease. It also helps you to resolve conflicts when merging contributions from multiple resources. Source control protects your source code from catastrophic and casual degradation of your human errors and unintended consequences, which can happen anytime in any project. Without version control, you are tempted to keep multiple copies of your code on your computer, which is obviously a painful job. It could be dangerous also. And that's why it is also case that it's easy to change or maybe delete a file, or maybe you're going to change the code in the wrong copy of your code, which can maybe eventually end up on potentially losing your work. And that's where source control is going to solve this problem. Explore the benefits of source control. Now, code does not exist unless it is committed into the source control. So source control is the fundamental enabler of continuous delivery. Without this, continuous delivery is not possible actually. Whether you're writing code professionally or personally, you should always have a version control your code using a source control management system. This includes a couple of benefits like reusability, traceability, manageability, efficiency, collaboration, and learning. And these are the common software development values which every software has to follow. You can work with multiple versions. You can create a step-by-step workflow where the process is going to be going through a particular pipeline, kind of a step-by-step flow. You can work with your team with collaboration. You can maintain the history of your work changes, and anytime you can go back to the previous version. You can also automate the task if you're focusing on continuous delivery. Well, there are certain best practices for source control which are mentioned here. We have to make small changes. In other words, committing early and committing often is a good practice. So be careful not to commit any unfinished work that could break the bill. The second thing is, do not commit personal files. It could include application settings or maybe SSH keys. Often personal files are committed accidentally, but it can cause a problem later on when the other team members are going to work on the same code. You should validate very often and right before pushing to avoid the merge conflicts. You should verify your code change before pushing it to the repository, which you have to ensure that it compiles and tests, and all the tests are going to be passing successfully. You should pay close attention to commit messages, as it will tell you why the change was made by someone. Consider that this kind of committing messages as a mini form of documentation for the change. You should link your code changes to work item so that it will concentrately link what was created and why it was created, and that's why it is providing more traceability across requirements and code changes. Last but not the least, no matter what your background or preferences are, be a team player and follow your agreed conventions and workflows. Consistency is essential for every team and is going to help you to ensure the quality, which are making it much more easier for team members to pick up where they left off. And that's the reason when you are doing code reviewing, debugging, or monitoring of your project for technical depth, then this is all going to be helpful to you when you are following this kind of best practices with your source control. Now let's talk about describing types of source control system. We already understood the benefits of source control system, but then what type of source control systems we have? If we talk about them, the first we have something which is known as centralized source control system, which are based on the idea that there is a single central copy of your project code somewhere, probably mostly on the server. Programmers will check into that same code, or what we call commit, and then they are going to have their changes which is going to be pushed to that central repository copy. Committing a change means a record the difference in the central system. Other programmers can then see the change which is happening on that, and that is what a centralized source control is all about. Now, as you can see on the slide, we have some strength of centralized source control, and it is perfectly best used for scenarios where you have a large integrated core base. You have audit and access control down to the file level kind of things which are there. Now in this kind of scenarios, maybe you can use centralized source control. Some common centralized source control systems are Team Foundation Version Control, TFVC, and CVS, Subversion, SVN, and Repos. All these are very popular and famous version control systems which are centralized. The other option which we have is we can have a distributed source control. Now over time, this is something which called distributed source control, which is nothing but a DVCS, which we call distributed version control system, for in short actually. Now the three most popular are Git, Mercurial, and Bazaar. Maybe you heard some of them, which are distributed source controls. These systems don't necessarily rely on a central server to store all the versions of your project files. Instead of that, every developer is going to clone a repository copy and has the project complete history in their local storage available for them. The copy or the clone of the repository has all the original metadata associated with that. Now, this one is coming with the strength like it can help you to deal with the cross-platform support. It has an open source friendly code review model via pull request. It is allowing you to work completely offline, and it is going to have a portable history where you can configure what history you want to store in your local. Now, this is going to be perfectly suited for a smaller size and modular code base. It is going to be helping you when you have evolving through open source kind of an integration. It is going to be highly distributed teams, so maybe you have a teams working across the globe and you have people working from different places, maybe with the less internet connections or maybe with the high internet connectivity. You can choose based on that. Some common distributed source control system, as I said, Git is the most popular one, and we have Mercurial also, which is picked by many organizations. Explore Git and TFVC, Team Foundation Version Control. Now, first difference which we can understand directly is Git is a distributed source control system, while TFVC is a centralized source control system. So obviously you got the pros and cons of both based on this. In Git, each developer has a copy of the source repository on their own development system, while on the other hand, Team Foundation server is going to have only one version of each file on their dev machine. Technically, it's going to be stored on the server. So in the server workspace model, before making changes, team member publicly check out those files and then they are going to use them. They also have an option of local workspace in which each team member copies the latest codebase version with them, and it's going to work offline as needed. Developers check in their changes and resolve conflict as necessary. So in TFVC, you can have a server workspace model, or maybe you can have a local workspace model based on your choice and the requirement of your project. Now, because in this particular course, we are focusing on Git in depth. If your company that relies on its software for a mission critical application, or maybe altering your development workflow can impact your entire business, in this kind of scenarios, you should choose Git. Now, developers mostly use Git because of these benefits which are visible on screen. You can have a benefit for community. In many circles, Git has come to be the expected version control system for the new projects. If your team is using Git, odds are you will not have to train new hires on your workflow because they will already be familiar with the distributed development. Now, what is distributed development? In Team Foundation version control, each developer gets a working copy that points back to the single central repository. Git, however, is a distributed version control system. Instead of working copy, each developer gets their local repository, complete with an entire history of the commits. Having a complete local history makes Git fast. It means that you do not need a network connection to create commits, inspect previous versions of file, or maybe you can do difference between commits directly offline. You also have another benefit, which is feature branches. One of the most significant advantage of Git is branching capabilities. Unlike centralized version control system, Git branches are cheap and very easy to merge. You also have an advantage of pull request. Many source control management tools such as Azure Repos enhance core Git functionalities with pull request. A pull request is a way to ask another developer to merge one of your branches into their repository, so that whatever new changes are there should be applicable. And because of all these advantages, ultimately we are going to get a faster release cycles. A faster release cycle is the ultimate result of feature branching, distributed development, pull request, and a stable community. This capability is going to promote an agile workflow where developers are encouraged to share more minor changes more frequently. There are three common objections which we mostly hear when people have to migrate to Git. First is they can say I can overwrite history, I have a large files, or maybe there is a steep learning curve which is associated with that, and people are not happy with that. Now, when we talk about each one of them, like if we talk about overwriting histories, Git technically does allow you to overwrite history. But like any helpful feature, if you misuse that, if you can create some issues with overwriting history, then it can create a conflicts. If your teams are careful, they should never have to overwrite history. But there are cases where people have done that and they have faced the issues with that. Second issue is large files. Git works best with repositories that are smaller and do not contain large files, or most of the time binary files with that. Now, even every time when you are going to clone the repository, they get the entire repository with its history from the first commit itself. Everything will be downloaded as a clone. It is great for most scenarios, but it can be frustrating if you have large files associated with that. In this kind of scenario, you have to use a tool which is known as Git LFS. Git LFS is a very famous tool which is allowing you to configure the large file system with that. It lets you separate large files of your repositories, and still it has all the benefits of versioning and comparing with that. Third issue, which is complaint like learning curve, is very much when you're going to use Git. Now, there is a learning curve, we don't deny that, but if you have never used a source control before, you are probably going to be better off when learning Git. I have found that users of centralized sources control like TFVC or Subversion battle initially to make a mental shift actually, especially around branches and synchronizing, because they are not familiar with that kind of a concept. But over a period of time, they like this new approach, they like this new methodology, because this is something which is going to give them a continuous integration feature. So once the developer understands how Git branches work and they get over the fact that they must commit and then they are going to push that thing, they have all the basics they need to success in Git. Now after this, let's talk about the last and the final module, which is module number 8, working with Azure Repos and GitHub. Now, as I said, we have a demo associated with Azure repositories, and that's somehow going to come in this particular course after Azure boards. But let's talk about Azure Repos right now. So Azure Repos providing two type of version control. It is actually giving you distributed version control also with Git, and it is also providing a centralized version control also with Team Foundation version control. So whichever your organization is preferring, both are available. Azure Repos are tightly integrated with the Azure DevOps features. It's actually one of the 5 tools of Azure DevOps. It can connect from common development environments where there is a list of IDEs which are connected, which are integrated with this, and it can have a policy-based management to protect branches associated with that. GitHub is the largest open source community, and I think everyone who's attending the DevOps sessions or everyone who's interested in DevOps, they obviously know what is GitHub. So it's one of the largest open source community in the world. Now Microsoft owns GitHub. I think you are familiar with that also. And GitHub is a development platform inside by the way you work actually. So there are a couple of features on GitHub which maybe you like it can automate from code to cloud, securing software together, seamless code reviews, coordination, code and documentation in one place, manage teams. All these are actually those features because of which people love GitHub. If you have already developed certain things on TFVC and now you are migrating to Git, that can be something which is really easy because most teams wish that they could reorganize their source control structure. And when they are migrating to Git, it could be an excellent opportunity to restructure your repository in that. If you really plan to do that thing, you can have a single branch import kind of a feature, or maybe you can do a full synchronization from using Git TFS associations with that. There are separate in-depth learning for this, but that will be out of the scope of this learning. So we are not going into in-depth into that. But yeah, you can migrate from TFVC to Git. When you're doing this thing, you have many steps which you have to do. So first you have to migrating the tip. So only the latest version of the code you're going to migrate. So history is going to remain on the old server. That is something which we mostly prefer and advise. Migrating with full history, if you're trying to do that thing, you try to mimic the history in Git and then you make sure that that is going to be stored inside that. When you are recommending to migrate the tip, because why we are doing this thing, because history is stored differently. In TFVC, it stores the change set, Git stores the snapshot of the repository. So the way we store the history in both is different. And that's the reason we advise that actually. Develop online with GitHub code spaces. Now this is one last part of this particular module, not very important from exam point of view, but yes, there is a tool called GitHub code space, which addresses several issues from which developers regularly suffer. Like these issues which are available here. So first, many developers are working with old hardware and software systems which are not refreshed. Second, maybe developers are often tied to individual development systems. Moving from one location to another location or system to system is inconvenient or slow to configure. That's the reason CodeSpace are having these advantages. So it can have and avoid issues with old hardware software. As I said, it will be totally highly portable. It can help you to protect against proliferation of intellectual properties. It's going to be based on Visual Studio Code. So all the Visual Studio Code integrations will be directly available inside that, like autocomplete, syntax highlighting, integrated debugging, and it has a direct Git integration also with that. It can work from PCs, tablets, or even Chromebooks. And then you can connect to CodeSpace from Visual Studio Code directly, seamlessly, without any issues. With this is the end of this particular learning path. We have 8 modules inside that, which are covering different parts of Azure DevOps conceptual understanding. But this is not the end. Once you understand the concepts, it's always important to do the labs. As we all know, you need to have an Azure subscription if you want to do this lab. And if you do not have an Azure subscription, we are partnered with Scalable, so we can provide the labs to you on the chargeable basis. Remember, it's not free, but yes, we have official labs available for AZ-400. These labs are going to be available with scalable.com. We have a lab number 1 at the end of this module, which is actually focusing on agile planning and portfolio management with Azure boards. In this particular lab, which is going to take around 60 minutes of time, you're going to manage teams, areas, iterations, work items, sprints, and capacities. You're also going to customize the Kanban board with different kind of options inside that. and you're going to define your dashboards. You're going to customize your team processes. This is all what you're going to do practically with step-by-step instructions. If you're going for the labs, this is going to be the lab number 1. And I'm going to see you in the next learning path, which is learning path number 2. Thank you. Okay, so now as we know, AZ-400 is actually having 9 different learning paths. Let's start with our first learning path, which is going to be starting our journey on DevOps. In this learning path, we have total 8 modules which we are going to focus, and after these 8 modules, we have 1 lab which we need to complete. The first module is focusing on Introduction to DevOps. We will understand what DevOps is actually. Please keep in mind, this module is focusing on DevOps, not on Azure DevOps. Azure DevOps is going to start after some time in the same module. After this, we have choose the right project, then describe team structure, and then choose the right DevOps tool. These 3 modules are going to talk about what kind of a project is a perfect choice for DevOps kind of an implementation, as well as what kind of a team and team members you can have. And then there are various tools which are available in the market, which DevOps tools you should choose. Then we have to plan for Agile with GitHub projects and Azure boards. And then we have to focus on source control. So we are going to understand what is a source control, what kind of flavors and options are available in that. And then in the module 7, we are going to describe the types of source control systems in that. Finally, the module number 8 is going to focus on working with Azure Repos and GitHub. So that's what the plan for learning path number 1. Let's get started. The overview of this learning path is going to have the same thing what we discussed. So these are the learning objectives which you will understand, which you will learn at the end of this learning path. As I mentioned, after completing this learning path, you will be able to understand this 8 different things which are mentioned there. And that's it. Let's move forward. We also have certain configurational things, like we have to understand the benefits of source control. We have to describe what is Azure Repos and how it is similar or different than GitHub repositories. And then we have to talk about migrating from your team foundation version control to Git. This is also something which we are going to discuss in the same learning path. Let's start with module number 1, structuring your Git repository. Now, if the question is, how should you organize your code repository? Then there are 2 main philosophies. First, using a single repository, which is known as monorepo. And then the second one is multiple repositories. Now, monorepo is a source control pattern where all source code is kept in one single repository. It's easy to give all the employees access and everything at once. You can clone it and then you're done. Organizing your projects into a separate repositories is referred as multiple repositories kind of configuration. Now, the fundamental difference between monorepo and multiple repo philosophies is what enables team to work together more efficiently. In an extreme scenario, the multiple repos view suggests that each subteam can work in its own repository. It allows them to work in their respective areas using the libraries, tools, and development workflows that optimize their own productivity. This segregation is mostly going to be helpful when you have a complex multiple team members with different modules and areas associated with that. Now, as we all know what is a repository, the definition is mentioned on the slide that a repository is a place where history of your work is going to be stored. Obviously, we know that. And then Azure DevOps projects can contain multiple repositories. There are 2 philosophies, as we mentioned, mono and multiple, which are there. The concept of changelog is what we need to understand, and we need to understand how we can implement changelog in our repositories. Now, this concept is very simple enough. It's a file that has a list of changes which you have made into that particular project. So technically, changelog is nothing but one file, usually in date order, so that we can keep track of things, which one is done earlier, which one is done sooner. The typical breakdown is a list of versions, and then within each version you're going to show what kind of new functionalities you have added into that, what kind of added features are there. If you have modified or improved certain features, then that will be mentioned inside that. Whatever features which are deleted, that is also going to be mentioned inside that. Some teams will post change logs as a blog post so that others will also be able to see that thing. and some other teams can create that as a markdown file, like changelog.md kind of a file they are going to create in their own repository. Depends upon the usage and configuration. We can maintain a changelog and your team members can get benefits from that. Let's talk about managing Git branches and workflows. Now, feature branching is a logical extension of centralized workflow. The core idea behind the feature branch workflow is that all feature development should take place in one dedicated branch instead of the main branch. And that's the reason feature branching came into the picture. Now, when you are using feature branching, you're always going to have one main branch and multiple feature branching associated with that. There is one more term which you need to understand, which is known as forking. The forking workflow is fundamentally different than branching. Instead of using a single server-side repository to act as a central code base, it gives you and every developer a server-side repository. That's what a forking is all about. It means that each contributor has two Git repositories, one private local one, and then another one which is a public and the server-side one, if you use a forking workflow. When evaluating a workflow for your team, you must consider your team's culture. You want the workflow to enhance your team's effectiveness and not to be a burden that limits productivity. Some things to consider when evaluating a Git workflows are: does this workflow scale with the team size? Is it easy to undo some mistakes and errors with this workflow or not? Does this workflow impose any new unnecessary cognitive overhead to the team? Now, this is something which we need to understand, and based on that, we have to evaluate the workflow. Most of the time, this feature branch workflow is going to look like this. The another name of this workflow is known as trunk-based workflow. Well, trunk is nothing but your main branch, and then other feature branching are going to be there. Assuming a central repository is there, the main represents the official project history. Now, the workflow is going to start like this. You're going to create a branch, then you're going to add commits into that. If some changes are there, you're going to open a pull request to take those changes from the branch. Then you're going to have a discussion and review your code kind of a thing. And then you're going to deploy and merge. This full process is something which is going to be followed in the feature branch workflow. Instead of committing directly to their local main branch, developers are always going to create a new branch whenever they are going to start working on the new feature. Feature branches should have descriptive names so that everyone can understand what kind of feature and what kind of branch is associated with that. Git makes no technical distinction between the main branch and the feature branch. So developers can edit, stage, and commit changes to a feature branch whenever they want. This is also going to be one of the best way to share a feature with others without touching any official code from the main branch. Now let's explore GitHub Flow. GitHub is the best tool to enable collaboration in your project, and we all know that thing. GitHub Flow is a branch-based workflow suggested for GitHub. Now, to implement GitHub Flow, you will need a GitHub account and a repository. That's it. The first step is to create a branch in your repository to work without affecting the default branch or a main branch. And then you give a collaborators a chance to review your work. Make any desired change to the repository. If you make a mistake, you can revert or push extra changes to fix it. Once you're ready, you can create a pull request to ask collaborators for feedback on your changes. Pull request review is one of the most valuable features of collaboration. You can require approval from your peers and team before merging the changes. Once your address review comments are already checked inside that, after the reviewer's comments and check validation, the changes should be ready to be merged, and then they can approve the pull request. After a successful pull request merge, there is no need for a remote branch to stay there, so you can delete your branch to prevent others from accidentally using the old branches. This is something which is a proper flow structure from left to right, which is happening every single time in GitHub Flow. Now, we also have a workflow called forking workflow or a fork workflow. The forking workflow is most often seen in the public open source project, and this is most suitable there only. The main advantage of the forking workflow is that contributions can be integrated without the need for everybody to push a single central repository. Developers push their server-side repositories, and the only the project maintainer can push the official repository. Now, most people get confused between the concept of forking and cloning. Let's compare both of them, because it's essential to note that forked repositories and forking aren't a special operation. If you have used Git, I'm sure you're familiar with the command called git clone. When you use git clone, this is going to create a copy of the repository local. The same thing is going to happen when you're going to fork your repository, but the only difference is this is going to happen at the server side. So fork repositories are created using the standard same git clone command. Fork repositories are generally server-side clones, not client-side. And that's the only difference which is between forking and cloning. It's going to be managed and hosted by a Git service provider such as Azure Repos. And there are no unique Git commands for this. So remember, there is no command like git fork. We only have a command git clone. If it is executed in the local machine, it's going to create a local copy of that. Or if you want a server-side repository, you need to do forking, which is internally going to do git clone only. Now let's talk about module number 3, which is collaborate with pull request in Azure Repos. This module is going to talk about how this collaboration is going to help you to understand the pull request work, and then how you can configure them. Pull request let you tell others about changes which you have pushed in the Git repository. As you can see here in the diagram, we have a branch, we have a discussion which is going on after that, and then finally we are going to do the merging part. This is what a normal procedure every time going to be followed when we have a pull request. Pull requests are commonly used by teams and organizations collaborating using the shared repository model. Pull requests combine the review and merge of your code into a single collaborative process. Once you are done fixing a bug or a new feature in your branch, you can create a new pull request. And the team members to the pull request so they can review and vote for your changes. Use pull request to review your work in progress and get early feedbacks on changes, which can make sure that you are going to have a good feedback and good code reviewing which is going side by side. Now we have a mobile app also available for Git pull request. Using a mobile app in combination with Git is a convenient option, particularly when you have an urgent pull request approval which is required. The app can be a render markdown, images, PDF files. Directly you can render all these things on the mobile device. Pull requests can be managed within the app along with marking files as viewed or collapsing files kind of a feature. You can also add comments if you want through the mobile view, and then emojis and shortcuts can also be rendered using this. These are all the good things of mobile view associated with GitHub. Okay, now in the module 4, we are going to explore Git hooks. Now, if you have worked with any web hooks, Git hooks are very similar to that, which allows you to trigger on certain actions. Now, let's see what is Git hooks. Now, obviously, first thing is what is the need of Git hooks? And in that, we need to understand continuous delivery, because continuous delivery demands a significant level of automation. You can't be continuously delivering if you don't have a quality code base. Git hooks are a mechanism that allows code to be run before or after certain Git lifecycle events. For example, one could hook into a commit message event to validate that the commit message structure follows the recommended format as per the standard compliance guidelines of the organization. The hooks can be an executable code, which can include a shell or PowerShell scripting, or maybe a Python logic, or maybe other scripts also. They may be a binary executable file, which anything goes on with that. It can be whatever you want to put it into that on the client side or maybe on the server side. Git ships with several sample hook scripts in the repository. So if you go to git/hooks directory, you'll get this kind of sample hooks with that. Git executes the content on the particular occasion and the type which they are approached. You can do practically anything with Git hooks. Now you can just check this kind of sections like, will my code break the other code, or maybe it's going to introduce any kind of a code quality issue, or maybe it's going to drop the code coverage. Now any of these chances can be there if you have developed some new code. Same way, if someone has developed some code, you want to check maybe will the incoming code is going to break your code, or maybe it's going to introduce a code quality issue, or maybe it's going to drop the code coverage, or in both the cases, you can take on the new dependencies which are coming into that code. How you want to use Git hook is your choice, and you can choose any of the hooks and execute any particular logical executions with that. Now let's talk about module number 5, which is plan, foster, inner source. Now the fork-based pull request workflow is popular with open source project. We already discussed about that. And it's popular in open source project because it allows anybody to contribute to a project. This workflow is not just for open source. Forks are also help supporting inner source workflow within your company. Now before forks, you can contribute to a project using a pull request. That is which is there. Now in this case, inner source is going to bring all the benefits of open source development inside your own firewall. And that's what a foster inner source is all about. We recommend the forking workflow for larger number of casual and occasional committers. When it is there, you should surely use a foster inner source for that. A fork is a copy of a repository. As we discussed, a local copy is a Git clone, while when you are going to do a server-side copy, that is which is known as forking. Forking a repository allows you to experiment with the changes without affecting the original project freely. That's the advantage. So what is a fork? I think we are clear with that. A fork is a complete copy of a repository, including all files, commits, and optionally all branches. A new fork acts as if someone cloned the original repository and then pushed it into a new empty repository. You can create a pull request in either direction, from fork to upstream or maybe from upstream to fork. The most common approaches will be from fork to upstream in most of the time. For the small teams where you have maybe 2 to 5 kind of developers, we recommend working in a single repository. As your team grows more significantly, you may find yourself outgrowing this arrangement and prefer to switch to a forking workflow. We recommend the forking workflow if your repository has many casual or infrequent commits which are happening on that. The forking workflow is going to be like this, as it is mentioned here. First, you're going to create a fork, then you're going to clone it locally. You're going to make your changes locally, and then you're going to push them into a particular branch. You're going to create and complete a PR to upstream like you do in the normal repository. And at the end of this, you can sync your fork to the latest from upstream. Module number 6 is talking about managing Git repositories, especially multiple repositories and the data of the repository. Now, when you have repositories, especially with the large repositories, there are 2 common causes which can cause a large repository. The first one is a long history is there inside the repository because it's an older repository with so many change logs happening in that. And then we have a large binary files inside the repository. Because of that also it can be large. Now, why repository becomes large? We already know the reason here as it is mentioned. Now, what is the solution? While having a local copy of a repository in a distributed version control system, which is functional, the large repositories can create a problem, especially when you do pull and push kind of operation. Now, first thing is, if developers don't need all the available history in the local repository, a good option is to implement a shallow clone. Shallow clone is not going to get the repository history with that. That's something which you can try. Or when you have large binary files associated with that, you can try a tool called Git LFS, which is Git Large File System, which is a perfect tool for handling the large files binaries with that. Now there is another way which is known as Scalar. You can work with large repositories using Scalar. So if you have a .NET Core application, which is you're developing .NET based application, then Scalar is available as a .NET Core application, which is available for Windows and Mac operating system with tools and extensions available for Git. And it allows you to handle a very large repositories to maximize your Git command performance with that. If you are using Azure Repos and you're hosting your repositories into that, you can clone a repository using GVFS, which is available from a particular URL, which is available in this particular slide and even in Microsoft Learn. And this is how Microsoft support Windows and official repositories with that. So you can register, you can unregister this kind of a configuration with the Scalar with that. So Scalar is that particular tool that helps you your Git repository to scale to some of the largest Git repositories. It achieves this by enabling some of the advanced Git features such as partial cloning or background prefetch. There are so many features which are available in this. You can check Scalar by yourself. It is important in this particular module just as a theoretical concept. You don't need to do any practical labs association with that. We have a purge repository data. While one of the benefits of Git is its ability to hold long histories for repository efficiently, there are many times when you don't need the repository, you need to purge data. The most common situations are where you want to significantly reduce the size of the repository by removing history. Yes, sometimes you have to do that. Removing a large file that was accidentally uploaded can also be an option, or maybe you want to remove a sensitive file that shouldn't have been uploaded there, but by mistakenly you have done that, like some passwords or keys or something like that. If you commit sensitive data, for example some password keys or like that, to Git, it can be removed from history, and there are two tools which are most commonly used. The first tool is known as Git filter repo tool, and the other one is known as BFG repo cleaner, which is again another tool which is helping you to clean your repository. These are some of the commands which are mentioned here, and you can try this thing on Git filter repo on github.com. You can manage releases with GitHub repos. How we can do that thing? So first of all, what is a release? Releases in GitHub are based on Git tags. So every release is going to have a tag associated with that. You can think of a tag as a photo of your repository's current state, like a snapshot. And if you need to mark an essential phase of your code on your following deliverables, which code is done, you can create a tag and use it during the build, and even you can use it to release during the release process also, to package and deploy that specific version. When you're using this kind of a tag, as we said, it's something like a photo or a snapshot of your repository. Is going to have all the information of the repository, and logically from this particular release version you will be able to understand the incremental behavior of that particular release. Finally, the seventh module of this particular learning path is talking about a term called technical depth. So we need to understand what is technical depth and how we can control that. So obviously the quality of the code shouldn't be measured subjectively. So a developer who's writing a code would rate the quality of their code high, obviously, if I ask them to do that. But that is not the great way to measure your code quality. Different teams may use different definitions based on the context, and they can say that their code is better than others. So how to measure the quality of the code? How can we actually do that thing? So the quality of the code is essential, and it impacts the overall software quality also. Basically, there are 5 traits to measure for a higher quality of your code. The first one is reliability. When we talk about reliability measures the probability that a system will run without failure, or over a specific time of a period it is not going to have any failure. Then second one is something which is known as maintainability. Maintainability measures how easily software can be maintained. It relates to the code base size, consistency, structure, and the complexity associated with that. The third one is testability. Testability measures how well the software supports testing efforts. It relies on how well you can control, observe, isolate, and automate your testing. Then we have portability. Portability measures how usable the same software is in the different environments. It relates to the platform independency, and that is also going to be focusing on how it can be extensible. After that, we have reusability. Reusability measures whether the existing assets such as code can be reused again or not. Assets are more easily reused if they have modularity or loose coupling characteristics. Somewhere in our structure we have discussed about microservice architecture, which is giving you some of these benefits where your code can be reliable, maintainable, testable, portable, and reusable. And if you have all these things, on top of that, you have to make sure that your code is going to have a secure configuration done with that. If you're following all these things, then it's going to be counted like it's having a higher code quality. Now, based on the complexity metrics, which can help you to measure the quality of your code, mostly it's going to measure program vocabulary, it's going to focus on calculated program length, the volume which is associated with that, the difficulty, and the efforts. Now, all these are actually common quality related metrics which we have previously talked about. Now, we have to check for this kind of metrics also in order to scale, in order to measure whether the code quality is up to the mark or not. Now, what is technical debt? Technical debt is a term that describes the future cost that will be incurred by choosing an easy solution today instead of using a better practices because they would take longer to complete. And this is a very common situation which almost happens in every bigger project in organization. So how does it happen actually? Now, the most common excuse is tight deadlines. In every organization, every developer complains about the deadlines. When developers are forced to create code quickly, they'll often take shortcuts. For example, instead of refactoring a method to include a new functionality, they are going to do copy of that code and they are going to create a new version of that. Now, this is going to increase the technical debt. Technical debt is one of the main reasons that projects are going to fail to meet their deadlines. Over time, it increases in much the same way the monetary debt does in real life. Common sources of technical debt are lack of coding style and standards, maybe lack of poor design and of unit test cases, ignoring or not understanding the object-oriented design principles, focusing on monolithic classes and code libraries, poorly envision the use of technology, architecture, and approaches. These are all the main reasons behind the technical debt. And once it is started, over a period of time, it will always grow and grow and grow if you just do not clear it. Integrating the assessment and measurement of technical debt and code quality overall is an essential part of your continuous integration and continuous deployment pipelines in Azure DevOps. When you're taking care of this thing, you have to measure and manage technical debt. You have to check these 5 characteristics. You have to check your failed build percentage. You have to check your failed deployment percentage, support ticket volumes, bug bounce percentage, and unplanned work percentage. If all of this are reducing with every DevOps cycle, then it means your code quality is improving. Suppose if there is a chance that any of these things are increasing because of the new release or the new feature associations with that, then it means your technical debt is actually increasing and you have to control it. Sources and impacts of technical debt. What can happen? Some common sources of technical debt are, as I said, lack of coding standard and lack of poor design. We already mentioned this thing. Same way, we have a poorly envisioned use of technology and architecture and approaches, over engineering code, insufficient comments and documentation in the code, not writing self-documenting code, taking shortcuts to meet deadlines, and leaving a dead code in place. All this can be some common sources which can generate a technical debt for your code. One key way to minimize the constant acquisition of technical debt is to use automated testing and assessment tool. In this case, we have a couple of tools which are available in the market, and we are going to use some of these tools in our practical demos when we are going to see the coming modules. We have a tool called Sonar Cube, and the cloud version of that is available as Sonar Cloud. We are going to use some automated testing tool, and in that mainly we are going to use Sonar Cloud as a practical demo of this particular module, where we will see that how it can help me to reduce my technical debt by doing some automated testing. So we are going to see that thing. But before we do that practically, you just focus on this particular terms right now. So technical debt is going to add problems during development that makes it more difficult to add value to your customers. Saps productivities and frustrates development teams. It can make your code both hard to understand and fragile, and it can increase the time to make changes and to validate those changes. It can start small and grow over time as like a monetary debt in the real life. One way to do this thing is automated testing, but we are not going in depth into this right now. We have so many tools, and we are going to see a tool called Sonar Cloud in the coming modules. Now, this is something which I have to mention, that you should discuss this thing with your team, that when you're migrating to Azure DevOps, which can be integrated with a wide range of existing tooling that is used for checking code quality during builds. What kind of a code quality tools you are currently using in your organization? You should make a list of this. You should understand those things. And then what do you or you don't like about those tools? Maybe you can find a better alternative of those tools in your organization. Now, if you drill into the issues, you can see what the issues are, along with the suggested remedies and estimates of the time required to apply a remedy. So you can see this is one screenshot which is showing me how we can manage the technical debt. It's showing me some issues which are identified before a couple of years also, and then in order to fix it, we just need a few minutes of task. If we do those things, we can complete that, and then we can fix it, and then we can just remove the technical debt from that. Now, you can also integrate some other code quality tools. Now, we are not talking about automated testing now. We are trying to improve our code quality. So we need some kind of a tool which can do a code reviewing for us. And there are two tools which I mentioned here. There is one tool which is known as NDepend, which is a Visual Studio extension that is available inside that. Mostly for .NET developers, this is a very common tool. And as it is available as a Visual Studio extension, which is going to assess the amount of technical debt a developer has added during a recent development period, typically mostly a last 1 or 2 hours. We also have a tool called ReSharper, which is also another popular tool for code quality check. ReSharper can make a code quality analysis from the command line, and it is also be set to fail build when your code quality issues are found automatically. So until unless you clear your code quality issues, it will not give you a successful build on that. Rules can be configured for enforcement across teams, so you can configure as you like. These are the two tools which you can keep in mind. Now, plan effective code reviews. Most developers would agree that code reviews can improve the quality of the application which they produce, but only if the process for the code review is effective. It is essential upfront to agree that everyone is trying to achieve better code quality. Achieving code quality can seem to be challenging because there is no single best way to write any piece of code, at least code with any complexity. Everyone wants to do good work and to be proud of what they have created. That's what always happens. It means that it's easy for developers to become overprotective of their code. The organizational culture must let all involved feel that the code reviews are more like mentoring sessions, where ideas about improving code are shared than integration sessions, where the ideas about improving code are shared than interrogation sessions, where the aim is to identify problem and blame the author. The knowledge sharing that can occur in mentoring style sessions can be one of the most important outcomes of the code review process, and every organization should do that. It often happens best in the small groups, mostly 2 to 3 people, rather than in the large team meetings. And it's important to highlight what has been done well, not just what needs to be an improvement. With this, we are done with this particular learning path, and at the end of this learning path, we have one lab which you need to complete. This is again an official lab which is focusing on version controlling with Git in Azure repositories. You are going to clone an existing repository. You're going to save your work with multiple commits. You'll change your code and then you're going to do the commit. And then you're going to review the history of the changes. Finally, you're going to work with branches, multiple branches, by using Visual Studio Code, and that's what the purpose of this particular lab. I request you to complete the lab by following the instructions which is shared on the link with you, and I'll see you in the next learning path.